This video is about accessing the elements in an array. Um, let's say we have an array, call it A, and I'm just going to write it out here, 2, 5, 7, 45, 99, 77, 1, 3, and 42. Okay, so now to access something, keep in mind these are across the top here we have the columns, and down this way we have rows. Remember, when we access an array, it's always rows, comma, columns. So if I did A accessed at 2, comma 3, this is row 1, row 2, row 3, column 1, column 2, column 3. So 2, comma 3 is the second row, third column, which would be the value 77. Okay, so let's look at this over here in MATLAB. I execute. There's A defined as we have it on the board, and on line 7 I set variable A equal to array A accessed at row 2, column 3, which gives us 77. Okay. Next up, on line 8, I'm not going to execute line 8. It will generate an error. I have it commented out here. But because what we're trying to do here is access A at row 5, column 7, well, there is no 5th row, there is no 7th column, so I cannot access beyond the boundaries of an array, just like I cannot access beyond the boundaries of a vector. I come down here on line 9, and we see something new. What this says is C equals A accessed at 2, comma, colon. Well, keep in mind the first one is rows, so it's the second row, and the colon means all. So this would be all columns. So second row, all columns. So the second row, all columns. You come down here to the second row, you take all columns. So C is going to actually get this vector here that's at the second row. So if you look here, C has been assigned the whole second row of the array, 45, 99, and 77. All right. So we come here next on line 10, and capital C equals A accessed. Now what I'm doing here is I'm accessing rows 1 and 3. We can have multiple values for rows or multiple values for columns. So I'm putting a vector in here. So we're going to access A at rows 1 and 3. So these are the rows. And then we're going to do all columns again. So we do all columns. So if we do that, and go back up here. So we're going to do row 1, all columns. So that's this one. And row 3, all columns. And that's this one. So as you see here, capital C, which is an array, which is why I have it capitalized, is equal to the row 2, 5, 7, columns 1, 3, and 42. So just like we did that with rows, we can do that with columns as well. So if you look on line 11, D is, so on D, we're saying give us all rows, column 3. So all rows, column 3, erase this one here, all rows, column 3. So all rows, third column, is what we call a vertical vector of 7, which is just one column, of 7, 77, and 42. And as you can see, that's the third column in array A. Come down here to D. Capital D equals A accessed all rows once again, and we're going to do multiple columns. And so I can even put a range operator in here. So 1, 2, 3 is just winds up being the vector 1, 3. And so we're going to do A, all rows, columns 1 and columns 3. And so capital D winds up being the vector 2, 4, 5, 1, and then 7, excuse me, the array 2, 4, with the rows 2, 7, 4, 5, 77, see, 45, 77, 1, and 42. Now, the thing that you can also do, which really this gets really sort of cool, is you can do multiple locations. So if we break this down, this is A at rows 1 colon 2 colon 3, comma, columns 1 and 3. So let's break it down a little further. So we have this creates the vector here. And so what you wind up with is you say, okay, well, I have rows 1 and 3, columns, the intersection of rows 1 and 3 and columns 1 and 3. So what I wind up with is, let me do this in the right order. So I take rows 1 and 3 and columns 1 and 3. And so what I wind up with are the coordinates 1, 1, 1, 3. Those are my row 1, columns 1 and 3, and then row 3, columns 1 and 3. So what I wind up doing is taking the values on the corners, in this particular case, 2, 7, 1, and 42. So if I run line 13, I get the 2 by 2 array of 2, 7, 1, and 42. So this is an introduction of how you can access the elements in an array. And we're going to use these same principles when we talk about assigning elements and removing elements from an array. Once again, the new things here are that you can do that it's always rows then columns, that the colon represents all, whether it be rows and columns depending on which locations it's in, and that you can do multiple rows and multiple columns, and you can do this thing like in E and actually access multiple elements that don't happen to be in adjacent rows and columns.